Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, and our guest today is Rob Rastovich, CTO of ThingLogix. ThingLogix is a platform and service provider that simplifies the process of building, deploying, and scaling IoT solutions. In this talk, we discuss the existing suite of IoT development tools available and trade-offs between the leading infrastructure providers. We also explored the evolution of IoT development from bottom-up engineer-led projects towards top-down strategic initiatives. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you would like to share your company's story or recommend a speaker, please email us at team@iotone.com. Thank you.
Rob, thank you so much for taking the time to speak with us today.
Oh, thanks, Eric. Thanks for having me. Appreciate you having me on.
So, Rob, I think ThingLogix is a super interesting company, and it's really, especially in this low-code kind of environment that we're moving to, very, very apt company to be discussing right now. But before we get into what you do and who you work with, I'd love to learn a little bit more about you personally. I'm actually from Portland, Oregon, so sister city just north of you. But I think it's interesting that I understand that you're actually, in addition to being the CTO at ThingLogix, you're also a cattle rancher in Bend, Oregon, which maybe, I don't know, a year ago would have probably seemed a little bit more odd. And right now, I guess that the feeling that you can actually be effective, while also ranching the CTO is maybe something that's more common. But how did you end up in that situation?
You don't find a lot of CTO ranchers around. The ranch that we live on in Bend is we're 102 years old. We're actually the first ranch in Deschutes County to reach 100 years old. It's still owned and operated by the original family. So it was actually my grandfather's. He homesteaded here in Bend back in 1919, and we've been, ranching ever since. The technology bug kind of hit me in the 80s when I first saw a Macintosh, and I thought that was the coolest thing ever, and never kind of looked back. We've been ranching here and for a long time, and it's actually, people always ask me, how do you get those two? How do they play together? And it's actually quite, I think everybody should be a rancher or a farmer in technology because they complement each other quite well. And I always tease that, in Bend, when I'm around, I'll be talking, most of the people that I know here are ranchers and farmers. And if I talk to them about IoT, they kind of look at me like I have 3 heads. ThingLogix is actually headquartered in the Bay Area. So when I'm in Silicon Valley and you talk to people there, I mainly know tech people down there. And when I talk to them down there about, where ground beef comes from, they kind of look at me like, really? It comes from an animal? So it's kind of a foot in both worlds, but they do complement each other quite nicely in terms of being able to be very cerebral in one and very hands-on, quite literally, in the other.
No, that's cool that you've been running this, or your family's been running this for 100+ years. When I saw rancher, I kind of assumed that it was, the story of CTO made some money in a startup and then, decided to go play with some animals in a farm. But I see this is really in your blood.
It's more like I don't know how not to raise cattle.
Cool. And then let's see, you've been with ThingLogix. Had you been with the company since it was founded, or? Because I think it might have been founded a couple of years before, if I'm correct, before you joined. Were you one of the founders, or did you kind of get recruited as a technical head early on in the company's life?
Yeah, we're actually one of the founders. So ThingLogix was actually born of a company called Telemetry. Telemetry was a startup that myself, my current 2 partners, and a couple other partners started in 2012 timeframe. And what telemetry was we set out in the IoT world. Back then, we called it machine to machine or M to M. But we set out to create a platform by which to ingest all this data because we believed even back then that IoT or machine to machine was the next big thing. And so we wanted to create a platform where you could do this enormous amounts of simultaneous connections and have millions of devices connecting and whatnot. And our goal actually was to sell it to Salesforce.com because we actually came from, all of us had worked at a consulting company for Salesforce. Long story short, we ended up selling that. Telemetry actually was acquired by Amazon and is today what is known as AWS IoT. So the IoT service that runs on Amazon was the technology that we pioneered over and back in Denver is where we were headquartered. ThingLogix was born out of that. Myself and my two other partners that founded ThingLogix, when after the acquisition to Amazon, we didn't want to go to Seattle because there's no place to put cows in Seattle. And so we decided to take the customers and provide professional services against the technology that we just sold to Amazon. So ThingLogix was actually born out of that idea of providing professional services around IoT and the technology that we had developed for AWS.
Okay, interesting. And that was a very quick sale to Amazon when it was only a little bit over 12 months or a year and a half or so between when you founded the company and when Amazon acquired it. Was that always the intent that you thought, okay, somebody is going to want to buy this technology. We just have to get it to the point where we've kind of validated that it works. So was that clear from the start?
Yeah, well, that was certainly our plan at Telemetry was to do that. And it started, we had a couple failures before that. So there was a couple other companies before Telemetry that we failed pretty good on. And then Telemetry was our last one. So it looks like it went quick, but it sure felt like it took a long time. But the goal was always to sell it. And like I say, our target suitor was always Salesforce because we thought Salesforce was going to, would be the natural parlay into IoT. And we had to run some stress tests against our infrastructure in order to prove that we could do the types of volumes of data that we were claiming. And so in order to do that, we had to spin up all these EC2 instances and we had to spin up a whole infrastructure. And it was such a large undertaking. Amazon actually called and said, "What are you guys doing? Why are you spinning all this up?" Because it looked, kind of looked like maybe there was some hackery going on there. And then they became interested in what we're doing and they ended up acquiring it before Salesforce got to the table, really.
Very interesting. Okay. No, that's funny. It's always kind of the story, isn't that entrepreneurship, you see the tip of the iceberg and it looks like these people were successful overnight. And then the reality is there's a tremendous amount of hard work under the water.
Yeah, there's a lot of stress under there.
Well, tell me about ThingLogix. So you started as a professional services firm. I understand there's now a platform. What does the business look like today between this mix?
We started out like I say as professional services, and their objective was really to be able to deliver IoT solutions quickly. We did come from the Salesforce ecosystem in terms of delivery and consulting and professional services around Salesforce, and we realized what Salesforce did for CRM. I'm sure Parker Harris and Benioff were sitting around one day and they said, you know what? Everybody needs a CRM and everybody is going to need a database and they're going to need to have a contact in there and it needs the name of first name and last name and email and phone number. And you need to have an account and there needs to be leads and opportunities. Why don't we just build all that and give it to them? And then, let people start to customize it themselves, abstract away all the complexities of DBAs and servlet versions and all that, and give them a web application where they can actually build a business solution. And that's what we really focused on in terms of delivering professional services around IoT. Our objective was to take the building blocks that you need in an IoT implementation. You need asset management, you need workflows, you need message brokering, you need integrations, you need security, you need all these things when doing a IoT delivery. And so our thought initially was, let's just build all this stuff and show up at the door with our bag of tools and say, hey, we can build you a solution quicker and faster than the next guy. Over the years, now it's evolved actually into its own platform, whereby now you can quite literally spin up an IoT application in a matter of minutes. And then we give you all those building blocks. And very much like the Salesforce paradigm to CRM, you can start configuring your way to an application very, very quickly. So our platform has become as much of part of our infrastructure, our core competency as as our delivery. So we still do professional services around the platform, but it always starts with the platform first.
Gotcha. Okay, so you've built up this microservice library. You have the architecture underneath, and then it looks like you're building up, if I'm correct, a lot of maybe kind of half baked or half finished applications around, or maybe templates is a better term, around particular situations. Like you have Boston Dynamics. Is it so? If that's a situation, is it that you've kind of figured out exactly how Boston Dynamics robots work, and you've built up the APIs and everything to work with them? And if somebody says, "Hey, I want to do something with Boston Dynamics," you're able then to kind of plug in and say, "Okay, we've got this 80% of the way there. We just need to now program exactly what you want the robots to do." So is it the situation where you're basically building up these templates and this architecture in advance so somebody can just customize it?
No, yeah, exactly. I mean, you definitely got it. The idea is, so we did take and we run on top of AWS. So all of our underlying services are the serverless resources of AWS. So we don't use any EC2s or any of that kind of stuff. Everything is stitching together these best of breed microservices on AWS into a solution. I always say AWS is like an auto parts store, right? It gives you all the parts, but you got to be the one to put it all together. And I think a lot of times it's difficult for everybody to understand what every service does. They use this one or they use that one. We've combined them all together to make a 100% serverless application. But you're exactly right. We then take and we build and we actually install Foundry, our product, our platform we call Foundry, is actually installed inside your AWS account. So you want an instance of our platform, we give you a CloudFormation template, you do a virtual double click, and it's installed inside of your AWS account, provisioning all the necessary resources. It provisions, the data stores. We have several hundred Lambda functions that it installs, and the APIs. All that stuff is now provisioned and ready to go. And so then we also have add-on applications that install then on top of that. So you're exactly right. The Boston Dynamics one is a great one with the Spot. We started working with Spot about a year or so ago, pre-pandemic. Our goal was actually to take Spot to a bunch of tech conferences and walk them around and show up, but that didn't work out very well in the last year. So, but yeah, you can now have a Spot implementation where we install and provision the necessary APIs and stuff to communicate with Spot. We have the same thing for people counting solutions. We have a people counting solutions where it does occupancy capacity of a facility. We have a product called WorkWatch, which does text-based health screening. We have one for water monitoring that you can install. So, and a lot of our customers will actually build up their own type of application on type of Foundry, and then they go and they start to resell their own Foundry-based application. So Foundry becomes the foundation to which, but you're exactly right. It's this templated vertical solutions that sit on top of it that you could then spin up and reproduce quite easily.
Interesting. No, I'm curious maybe how you came to this point. We've seen interview a lot of platform companies, and then IoT ONE, we also do a lot of research in the area. And for a long time, there was this kind of tension where somebody would build a platform and it maybe has all of the required functionality, but then they find out that their end customer doesn't have the people to actually develop those applications. So you end up with, a platform that has great horizontal functionality, but no kind of vertical, applications or specific use cases that can be easily deployed. And you hit this big bottleneck for actually getting things done. And then on the other hand, you have these SaaS solutions which provide, one specific functionality. Salesforce, for example, which are doing quite well in the consumer or the traditional internet at least, but it's a little bit challenging in the industrial IoT because things are a bit more customized than they are in the enterprise. I'm curious, how was this kind of intuitive from the beginning that this is the direction you had to take, or was it specific customers that led you down this path and just saying, okay, this seems to be what the market wants, so let's build our business, around a horizontal platform, but just over time build up this library of applications or application templates that we can provide? What was the thought process there?
I wish I could say, yeah, that was my intention and I knew it from day one. That's exactly what we were going to do. But it really was, I had being the architect of the platform. And when we were at telemetry and we were ingesting all this data, having spent 30 years in consulting and delivery, the first thing I look at is like, where do I put my code? I have data coming up. I have a device. It's connected. It's chirping. It's talking to me. And now I need to put logic in there. I have to put some logic on my things. And it wasn't necessarily, there's rule-based stuff and whatnot that we kind of came with the ingestion layer, but everybody needed this ability to put logic and customizations around these devices and interoperability between the devices. So at first, it was very much, all right, and that's ergo the name ThingLogix. Where do you put the logic for your things? Where does that go? And at first, it was really just trying to create a framework so that it was a repeatable pattern and a scalable solution so that, as a developer, I could go in and go, okay, I got 1 million devices and I need to say if temperature is greater than 100, then do X, Y, and Z. Or if water does exist, then tell the pump to turn off or get some predictive maintenance. I need a place to put all these kinds of things. And that's really what we set out to do, was to create a platform and a framework by which to develop IoT applications. It's very difficult to sell frameworks. It's very difficult to sell platforms. VCs don't really want to talk to you about how great of an architecture you got and that you're infinitely scalable and how much time you spend on security and how a Lambda function can fire and all the different things. They want to know, what is it you can do? How can I take this to market? And we found out very quickly that the story to talk about a platform is everybody has a platform and you can't do anything with a platform. It was the first one was this smart home. And we had a customer who said, all right, I got 100,000 rental properties and I want to outfit them with smart thermometers or smart thermostats, leak detection, smoke, all these things. And I want a solution that I can manage 100,000 of these properties with. Well, that's a big ask and you need a big infrastructure. And we had something to do that. But we also realized then, it's easier to go out and sell, here's a smart home solution. Okay, we got that. And it just happens to ride on top of our platform and we can get it going. And the smart home solution can be spun up and installed. And again, it's probably, if Foundry gets you 80% of the way there, the vertical solution probably gets you 90 or 92% of the way there. And you customize the last part of it to meet your specific business needs. But those types of things, refrigeration, cold chain, manufacturing, smart cities. We got a couple cable companies that are using our platform and then they reuse it and they build their solutions on top of that and then resell it to their customers. It became quite evident early on that while I think the foundation was technical and the platform itself, it was important to have a good hardened architecture on it. The sales side of the house works a lot better when you have a specific vertical that you can go after.
And what does the business or your customer base look like today? If you look at different industry verticals and different, SMEs, kind of mid-sized companies, larger corporate, are you just all over the place? Are there particular segments where dominate your business?
It's really interesting because we have municipalities that use our platform. We have startups that use our platform and pretty much anything in between. And I wish I could categorize it around, their traditional KPIs, mid-size companies of this volume of, this amount of revenue or this amount of, or this particular industry. But right now it still seems, it still seems to me the way that I always categorize it, even internally, is our market are those people who get it. I think we've been doing this for a long time. And I think we've always had a solution to a problem that most people didn't know they had. And I call it the IoT life cycle. Like the IoT life cycle goes, okay, I want to connect my device. I got a temperature sensor. Can you connect it up? We go, yeah, we can connect that up. And look, here, data's flowing up. And I can show you a little console and you can see messages flowing. You can see your MQTT feed. And you go, oh my gosh, that's so cool. And then the next thing they say is, can you put it on a graph? Well, yeah, I put on a graph here. You can see a graph. That's so cool. Then they say, well, can you have it send me a text message when temperature gets to be 100? Yep, I can have it send you a text message. And then they say, then they say, okay, can you connect 10,000 of them? Yep, we can. And then they have what I call the oh shit moment. They go, oh shit. Can you stop the text messages, get rid of the graphs, and can you make the thing smart enough that I never have to deal with it again? It should be able to fix itself. And those are the companies that start to get to it when they and there's that process. And some of them get there quicker than others. We have municipalities that get there pretty quick, and we have larger municipalities that take a much longer time to get there. You have entrepreneurs that one day you start to explain what a connected device does and talk about it. The lights just kind of go on and they go, oh my God, this is going to be amazing. I can do this and I can do that. So I always say our customer base are those that kind of get it. And, quite frankly, the whole COVID thing where people have now de-urbanized and kind of moved home has really started to get people start to thinking about their business model and, how they're going to work on that. And we fit right into that. They're actually starting to have the problems that they have the problem that we solve. And the lights are starting to go on. So it goes across industries, it goes across size, but I think it's going to start leveling out a little bit in terms of the size of company that we can service.
That's a good way of describing it, though. I think we see this quite often, as well. But it's a bit challenging. Sometimes it's very clear, right? We build a SaaS application for some particular asset class, right? But often it's a bit challenging, but it does tend to be, okay, we work with companies that understand what we do, and if they don't understand what we do, then, it's too challenging of a process to try to work with them. So it's more important the mindset, as opposed to what specific industry they're in many cases. I imagine that also means because you're working with such a variety of companies, that the business model also differs, right? If you're working with a startup, they might just say, hey, this is a great platform I can build on. Let me access the platform and run with it. If you're working with a municipality, maybe they say, okay, here's the budget. I want you to build this solution and make sure it works. So you have the platform, you have applications built on top of the platform or application templates, and then you have your services. So is it kind of three different business models that might apply? Maybe all three of them could apply to one situation, or somebody might say, I just want the platform or the platform and an application. What does that look like from a business model perspective right now?
And that's a question we struggle with every day internally. What do we want to be when we grow up? The answer to that question seems to be different depending on who your audience is. If you're talking to a potential investor, you're talking to a potential suitor, or you're talking to a customer. Sometimes it varies, but it's a very good question. And it's something that we do ponder quite a bit. So I think right now where our revenue is split, we're almost 50-50, platform licenses versus professional services. But it does depend on the customer too. So our pricing model is we have basically an all-you-can-eat model. Enterprise licenses, take all you want, and this is the fee. Some of the startups they come to us and they say, all right, well, we don't have resources, we don't have development resources, but can you kind of take care of it for us? The Foundry is a multi-tenant architected solution. So we actually run a couple of our own instances that are multi-tenanted that you can, log in, and we give people the ability to kind of, try before you buy. And then some people just never get above that tier. But for startups, they want a per device model. Like, okay, every time I turn on a gateway, it's $1 a month. Or we have X amount of trailers out there and I'll pay 50 cents a month for the trailers. Some of them are more in terms of data consumption, because in IoT, you're going to have 1 million devices that chirp a little bit, or you can have a few devices that chirp a lot. And in terms of processing power and actual hard costs, those two could look very much the same. So in the one where you could have a few devices and they're really chatty and they're chirping all the time and it's very complicated and you're doing a lot of integrations, that could be just as expensive in terms of compute power and cost as 1 million devices all chirping once a day. it kind of depends on the model, and we try to be flexible for each, but make so that it makes sense for the customer. But you're right; it does fly all over the board on that.
Yeah, I mean, it's always the case in IoT, right? It provides this tremendous array of opportunity for business model innovation, but that also makes it very challenging to figure out how exactly should we price for something. I mean, for your customers as well, I imagine they have the same challenge, right? They're building some device or some solution, maybe using your architecture, and how are they going to charge their end customers?
Yeah, and they're trying to figure out their business model. We're talking about, when we talk a lot about the connected economy or the subscription economy, I think the more we're actually moving towards this subscription type economy where, we have cleaning as a service. We have connected vacuum cleaners that are looking at doing cleaning as a service instead of you going and buying a vacuum cleaner every 2 years and then not knowing what the bag is that it goes in there, and you don't know where the filter, how to change it, and the belts break, and 2 years later new technology comes out. Actually, they're looking at the idea of doing a vacuum cleaner as a subscription. I'll give you the vacuum cleaner, the filters will show up, the belts will show up when you need belts. You can we'll swap it out, and in 2 years when new technology comes, we'll give you a new one. This whole subscription type economy is really driving that a lot. And that business model on the subscription-based economy depends a lot, obviously, on the per unit transaction. How much does it cost to keep a single unit going?
Yeah, that's right. How much more efficient can you be if you centralize this and really understand how it works, as opposed to selling the device and letting everybody else figure it out? So there's actually one thing that just struck me as you were describing your model, which is, who are you selling to? Because this mentality topic is so important. And there's the kind of traditional or much discussed, IT OT divide, where maybe the IT folks, it's much easier for them to understand maybe your value proposition, but the OT folks are the guys that are really running the core business and are going to be most directly impacted by anything that you do in many cases. Who are you usually selling to? Is it which functions, which individuals or titles would be the people that you would actually be working with here?
That has dramatically changed over the last 5 or 6 years. So when we first started this, we were working with, the engineers in the basement who had heard about, machine to machine or IoT. And they're like, they got a Raspberry Pi and they, was able to turn the light on and send some data up. And they were trying to do this bottom up, and they were going into the enterprises going, I got an idea. Why don't we connect, and we can connect this, and they would have to kind of get support from the top and try and make their case all the way up. But these days, it's really coming top down. I think IoT is prevalent enough, and people are going, and enterprises, they got a long way to go in terms of, I think, re-engineering their business models to fit an IoT or a connected economy. But the C-suites are actually starting to take notice and going, okay, I think we could have a competitive edge with this. And now bring it back down to the basement and going, okay, this is what we would like to do. I think we can do this. Now, can you guys help make it happen? And we still do get, the technicians. We have lighting companies where we're creating, mesh networks in the fixtures and whatnot. And it's just now getting up to the point where they said, okay, well, it's stable enough. Yes, we've proven out the concept. Let's take it to market. So there are still some bottom up, but I think we've at least crossed the halfway mark. We're talking to the business folks, and they're trying to come up with the value proposition for their particular industry, and then bringing it down to the IT and say, okay, guys, how do you make this work? And a lot of IT is still trying to figure out. There's still a lot of IT departments who, you say MQTT, they think maybe you misspoke HTTP, right? And so they're looking to, have someone to guide them how you handle this event-driven type of architecture, as opposed to the old request response stuff that, is still most prevalent.
Gotcha. Yeah, makes sense. Well, let's get into the tech stack a little bit here. So you've already described, kind of high level what the architecture looks like, or that you're at least building on the AWS architecture. Is that the same for AI solutions that I understand you're also developing now, for example? Are you primarily building there also on AWS's solutions? So can we understand this as basically you have used AWS as the toolbox, as you say, and then you're using that, kind of combining those parts into different modules, but underlying would be primarily the AWS architecture. Is that like a fair description?
It is. Yeah. So because of the acquisition, at the heart of ThingLogix is still the AWS IoT core, which, we were part of. I mean, it's very different today than it was, 5-6 years ago, but that was at the heart of it. And then everything else starts to surround that event-based message bus that comes through there. That being said, we also have started branching out. So we haven't released, but we are in the works of an Azure stack, and probably way down the road, another stack that may run off of some of the Google platforms. Now, we also have a interconnected stack. So we have customers who may be using, Azure's ingestion layer, but their developers want to use Lambda functions. And we have the opposite. We have, okay, fine, you can keep your Lambda functions and use Cognito for your security and all that other stuff, but I want the data sitting in a SQL server. Well, that's fine too. We can do those hybrids and move them over. We don't have a full 100% Azure stack yet, so we still have the hybrid, but we are looking to do that because we've actually been getting, as of late, more requests for an Azure stack, or at least a choice between AWS and somebody else. Because most people, especially if you're in the consumer retail space, there's a lot of consumer products that are IoT, of course. There's a bit of a hesitancy to, do anything Amazon. While technologically, we know there's really, very little that, Amazon's going to do or can do with your data, but it does the optics of, Amazon coming in and having all your data. Some people don't like it. And then plus, because we have a very large Middle Eastern division, so our Middle East and Dubai is probably our fastest growing segment by far. And that data needs to stay resident in the UAE. And so we'll have a fog type of solution so that the data at rest is actually either maybe sitting in a data center that is in the UAE, but Amazon has just opened up another data center there. So it's not as big of a problem, but still keeping it in country. In Europe too becomes an issue. So doing some of these hybrid solutions definitely is part of our DNA.
Makes sense. I'm sitting here in Shanghai in China, and that's always top of mind, right? How do you manage data across borders, right? Especially, you have a lot of manufacturing bases here, and of course, headquarters would like to see what's happening in production. And I think right now it's still a little bit of a gray area where you can kind of do what you think works, but makes most sense. But there's still kind of a regulatory framework that is not precisely defined yet that will have some impact there. How does that typically work then? So, because I guess you have a similar situation where there's somebody outside of the entity that would like to aggregate data, but there's some government regulation that requires data around, PPI or something that's held in country. So do you then store that data in country and then somehow aggregate it before sending abroad, or how do you manage that, or how do your customers typically prefer to manage that?
Well, if the requirement is that it all has to be in country, and so right now, if in flight and at rest have to be in country, we don't accommodate that. In flight, so if data is coming up and is being ingested, but is at rest in another country, then we can, because we're all 100% API driven, so everything sits on top of an API. That API happens to be served up through Amazon's API gateway, but it just decides where the data is going to go. So if the API says, okay, well, the data's in flight and I got to store it someplace, don't store it here, store it over there, then it goes over and gets it. So there's switches inside the API and configurations that allow it to move the data to where you want to do it. So you can do, and we actually, for POC, we ingested on Azure. It was in flight on AWS and stored and big data on Google, and then ran, or Microsoft Functions and Google Go on each of their platforms. So just being able to call them, but it's still for the purists that wants it 100%. And we do, especially in the Middle East, they want 100%. Even in-flight data can't go out. It can't go exceed the borders. So that is what we're working on, and kind of be probably not this year, but next year we'll have a fully in-country solution. But it's also, we're going to be riding the coattails of some of the partners, because like I say, AWS is putting a lot of resources in that. And I'm not sure what Microsoft's plans are for that, but I know that they're a little bit more easy to be on-prem.
Yeah. They do a lot of manufacturing, I think, and then on-prem is. I'm curious your perspective on what differentiates AWS, Azure, Google. I understand, and maybe you're a little bit biased here, but my understanding also is that AWS IoT has traditionally been kind of the market leader in terms of bringing functionality to market. But what does this situation look like today? Are there significant differences in their capabilities, or in terms of their ease of working with these different platforms, or are they kind of converging around a certain set of functionalities and processes?
Well, thanks for saying that AWS IoT is the market leader. We appreciate that. It's a moving target. We actually, I think that the recognition stuff that Google has, I think, has been far superior than what Amazon has. Amazon just came out with the text extract recognition. We were using Google's photo recognition and text extract recognition and all that stuff long before we used Amazon. So for whatever reason, they just seem to do a better job at that. I think the Microsoft stack, I would say, to me, the Microsoft is a little bit like, the Netscape Internet Explorer thing. Back when the internet was young, and so was I. Netscape was the only browser we had, and Microsoft was a little late to the party. But once they got in and got going, they exceeded Netscape and what it could do in terms of volume of people that were using it. And I mean, they also had the platform for it. And then because it came installed on every computer, didn't hurt either, right? I do think that you're seeing that same kind of paradigm. I think Amazon got the jump on everybody in terms of IoT and the whole serverless thing. But I see it's not going to be a one-horse race at all. I think Microsoft is fast approaching and catching up quite quickly. One of the advantages I think you have, obviously, with Microsoft is, I always think of Microsoft more as, a development, an IDE. Azure is as much to me an IDE as it is, as opposed to more what Amazon is, which is microservices. If you're going to be an Azure developer and you're going to get in there, you're going to have everything at your fingertips, and you want to make a data store, you just spin it up and you make it. And all these things are available within even your development environment. Whereas Amazon, you would have to pick and choose and get these services over there. So I think Microsoft has a little better in terms of their developer network. I think those, if you're a Microsoft developer, you tend to be pretty loyal. And I think it is a little bit easier in terms of being able to, spin up these solutions than you can on Amazon, because Amazon doesn't give you that ability. You got to kind of understand each one of them a little bit. So I think, and I don't know the numbers in terms of amount of users on each one of them, but I would just say from having worked with each one of them that Amazon has been at the forefront, but I think it's going to be a pretty good horse race here.
Yeah, good. Well, that's good. Competition is useful here. No, and it's interesting perspective that they all differ. I mean, in terms of usability and also some of the functionality. On this AI topic, it makes sense that Google would be a bit ahead there, just based on their, that's really the core of their business. Where are you today in terms of? I guess you're using different AI solutions based on what type of problem you're approaching. But AI, there's always been this kind of challenge in the past where you say it's AI, but then under the hood, it's either in the worst case, it's a bunch of people sitting in an office somewhere, a bunch of monkeys typing code. In the best case, it's a bunch of data scientists, also putting in tons of hours to somehow extract insight. What are the use cases today where AI could really works as people imagine it should work, which is, with relatively little human labor, you're able to extract some insight from a complex situation.
I think you're right. I think there's a lot of quote unquote AI out there, and some of it is just, there's some AI that people call an AI that's a bunch of if-else statements at best. At worst, they're like, doing string parsing to see if it contains a word or something. So AI and getting a prediction, getting a result out of artificial intelligence is kind of the easy part, right? To me, the hard part, and I think we don't pay enough attention to this, the hard part and the most important part of AI is the learning part, the teaching part, right? Getting it that data that makes it smart enough to actually give you a usable and accurate result. What Foundry and ThingLogix can do is we actually do very, very well at that learning, facilitating that learning model. So for example, let's just say you have a connected washing machine and it's sending up, about 12 different points of data. Well, in order to get your AI model to do a predictive analysis of when that washing machine is going to break, you need to have a whole bunch of data. So let's say the washing machine sends a data every minute. So you need 1,000 minutes of data coming up. But the most important thing you need is somebody to go right there at point number 1023, it broke. That was at the point that it broke. And at 1200, we fixed it. Okay, so now we have a data set that is reliable that says, oh, it was good. And now we broke it. And it was good here. And because we have all the data coming up and we can set those kind of initial alarms and results, and you can see those, you get a good historical data. So once you say, all right, now I've got 100 of those, and I got 100 washing machines, and I got 1,000 minutes in each one of them, and it shows exactly where the pain points was, and I was able to collect that across 100 of them and give that to the data scientists. Now I can take that model, send it over, and start getting real good data. Because back in the early days, the very first thing any of us learned in programming was garbage in, garbage out, right? That is so much more true with AI. If you teach it incorrectly, you can have artificial ignorance probably easier than you can have artificial intelligence, because you can easily get a bunch of bad data, and that's kind of the fear that is out there amongst the non-technical is, well, what if the AI either A, knows way more than I want it to, or what if it's wrong? So I think we really kind of focus on that. All right, let's get the models, let's get those data models so that we can, get good, clean data, have it verifiable, and then improve the model that teaches them. As far as the algorithms, they're just getting, they're just getting better and better. And, when we first did this, it was, Amazon came out with machine learning. They had the one algorithm. And now with, SageMaker, and, we have, you kind of pick your flavor, and then Google has several of them, and even the GE, the Predix and IBM's, and there was that Watson, I guess they have. So they all, I think, going to kind of flush out to be, reasonably good. But to me, it's who's teaching it and what are they teaching it? And I think that's really where we can really excel. We did a test with the NFL, like I'm sure everybody else did. And we, inputted a bunch of player data and then matched up teams and see how we did. And we got pretty close. I think the one interesting one was we had a water polo. We were working with Olympic water polo team, and they were tracking kids, stats. They'd run them through basically a fitness course, and they'd track, how fast they run, how fast they threw the ball, various things outside of the game. And we put those in the model and then put the teams together, and it came out to be 100% accurate as long as the score was greater than, I think, 8 points apart. Right. So as long as it was basically a blowout, we got 100% accuracy. We got really good. But when the score got really close, it came down to intangibles like, the coach and what did they have, for breakfast and who was feeling what. So I think the models that we're going to get are going to be just that way. I think right now AI is really good at the obvious and the blowouts, but it's going to get better. And in order for it to get better and better and better, it's going to need to get, the data points are going to have to get more and more granular and more and more accurate. And I think that's one of the things that we do really well at.
Yeah, no, that's a great point. And I guess that's the other challenge here is getting access to good, high quality data in a reliable way, which you're also working on. Maybe we can run through a few case studies here. It's great to have this perspective on what is the objective of the case studies. Are we trying to get reliable data? Are we trying to automate and apply some sort of machine learning? Maybe you can just give us a little bit of the background of what was the core objective here? What did you do? And then what was the result?
So a couple things. One that I think is really interesting, we're obviously an IoT company, but the United Way had approached to us. They had a grant and they wanted to create an application that helped people get out of poverty in the Silicon Valley. So what does that have to do with IoT? Well, it occurred to us that, a business or an agency is nothing more than something that chirps data. And so what we did is they wanted to create a system by which you could have a common view of someone who needed assistance. So if they went to the food bank, you would know who they were there. And then if they went to a job training, and then if they went for shelter, and then if they went for, childcare, being able to, all those agencies had different systems. They all couldn't integrate with each other. It was very expensive to integrate. And so essentially we just enabled the database, because the database is a device too. A database can chirp and send data just like a temperature sensor. And we actually have little, plugins that go on to all the major databases that allow them to chirp out, data that's been deemed chirpable. And it was able to bring it in. And as we brought that data in, you could follow the care of an individual across the agencies. And the United Way could then look at that and then provide holistic care to that individual. And then also they would be able to appropriate funding accordingly to where they saw the need and where it was being used the most. So one example that was not IoT related in the sense of it wasn't a device, but something that's chirping. And people always say when we talk about the Internet of Things, I always say we should be talking about the Internet of everything. Everything is connected. When I say connected, I mean anything that can speak, anything that can chirp, can send a message. And that can be a temperature sensor. It can be a database. It can be a business. It can be a person sending a text message. And all that data, that connectivity needs a place for its logic to go. So that's one that I think I wanted to bring up as a really good use case that we were able to build an event-based, message-based architecture on top of an IoT platform. It worked really well.
That's really fascinating. My intuition has always been that this issue in the Bay Area is somewhat of a local issue, but it's also, if you pull that string, far enough, you might find that people from across just as engineers from across the world migrate to the Bay Area to work engineering jobs, people that are in tough straits, also probably to some extent migrate there because they provide good services and they have a nice climate. And, if I'm living in Chicago, in the winter, I might think, hey, you know what? Better to be in San Francisco right now. Let me get a bus ticket. And then you come across this bigger problem. Okay, you get the data locally that points to the path people are following, but how do you track that back to the places where they're they're first encountering challenges where they're, maybe they have, there's abuse in the family or drug issues in the school, whatever that might be. And it might be 10 years before you're actually contacting that individual in San Francisco. So like you said, it's, just the more data you can pull together, especially in a situation like this, where there's a human life cycle. If you don't have that data, you're only looking at a snapshot, right? And very hard to make right decisions.
Exactly. Yeah. You're not getting the whole approach, And it'd be the same thing, if we talk traditional IoT, you don't want to look at just one device. You want to look at where that device sits in context. What factory is it in? What line is it in? What is around it? Who, and having that context involves a lot of different stuff. It involves metadata. It involves actual data from the device. It involves metadata. It involves integration with other systems and bringing those in. It involves security. It involves the ability to cause and effect. This needs to do this. And you need to be able to put some if, then, else statements someplace, right? All that needs to be available. And that's really, at the heart of it. When you start trying to deliver a solution in an event-based IoT world, you come across these problems. And that's what, ThingLogix actually became to do, is to solve those. One of the other use cases we had came up during COVID. We actually spun up, this is one of our vertical solutions that we spun up, was the idea of schools and kids returning to schools or being at schools and being able to do self-health assessments, being able to track who was at school today, who was on campus today, who was in what classroom, all those kinds of things. So we ended up getting, again, students as a device, if you will. The system would text message every student and say, all right, you got to take this self-assessment. So a little chat bot walks them through their self-assessment for that day, returns them a QR code. And then we have at the schools kiosks that where they walk up to it, they scan the QR code, it recognizes who they are, that they have passed the self-assessment, takes their temperature, lets them in. And then the teachers have mobile app version of that. So as they come in the room, they scan them. And as they go out the room, they scan them. So they turned out very, useful in the sense of if they had a reported case of COVID, they could track really quickly to, where the students were on campus. And it gave the parents peace of mind as well. And so that we actually worked with the school administrators, actually came to us, and it changes day to day on that one. Say we have a compliance issue that it's this, today, this is a compliance requirement from our particular county in our particular state. And then it changed the next week and it continues to change. It's starting to stabilize a little bit now, but with the platform, we were able to make those adjustments really, really quickly. It's not, the platform doesn't require so much change in so much code that as compliance needed to change and paradigms needed to change, we could adapt to that really quickly. And probably the third one is probably really more as strictly IoT is we do river monitoring. So the challenge there was really they didn't have the ability to put a connected sensor into the water where we wanted to measure flows. The idea was to measure flow coming down this river so that you could, for flood control and, those types of things. But more importantly, like the amount of water coming down this river today determines how much, and this is what's near and dear to my heart, how much irrigation water the farmer gets, a week from now. And so we put in a recognition video camera that had two fixed points on either side, and some smarter people than me came up with the algorithm to determine the water flow coming through those fixed points. When that data comes in, being able to process that in real time, and then being able to provide water predictions for agriculture and farmers, in some cases, hundreds of miles away, because all this water is coming from a particular thing. And that's a really, water conservation, being able to manage our resources efficiently. To me, that's really the really exciting part of what we do. Everybody always, talks about our dark side of, we think we're collecting too much data and we know where too much things are. Well, I think our a real bright spot in that is being able to do things like do water efficiencies, environmental efficiencies, agricultural efficiencies, and really be a technological solution to some real ecological problems that exist.
Yeah, absolutely. I mean, this is just a very powerful tool, and you can hopefully we'll use this more often for good things than for bad. But it's certainly a very powerful tool. Great. I mean, Rob, this has been really an interesting conversation. Is there anything either that we haven't touched on yet that's important, or anything that's maybe around the corner for ThingLogix that you want to share with us?
Well, I say that, kind of our vision, we did just come out with an edge technology as well. So we're trying to actually take the platform more to the edge. So we obviously started as a pure cloud initiative, but we're taking some of these microservices down to the edge, our recognition and stuff, but doing more processing at the gateway and level. And, our vision really is to become cloud of clouds, to a system that doesn't really exist necessarily on AWS, doesn't necessarily exist on Azure, or doesn't exist in Google, and it doesn't exist on-prem, but it exists in all those places and none of those places. I think that as I look at the future of what this holds, it's just going to become more interconnected. And I think we're going to need that. I imagine a day when we can determine, all right, well, compute power happens to be cheaper on Azure today, so I'll run it over there as opposed to run it on AWS. So that's one. And I think you're going to see ThingLogix coming out with a lot more of these vertical solutions. We got some exciting ones that I think are in the hopper right now, where we're going to be able to spin them out. And, we're actually looking for partners to help run those vertical solutions. We don't want to actually be in the business of running those. We want to be able to spin them up and do it. So we keep looking for partners who want to run these business IoT types of solutions as well. So that's kind of what our direction is for 2021.
If a partner or potential customer wants to get in touch with you, what's the best approach?
Go to our website. We have all the traditional ways of getting a hold of us with email, but no fax. So you're gonna have to call or email us. By all means, get a hold of us, and you're welcome to contact me directly. Just rob@thinglogix.com, and we would love to share the wealth.
Awesome. Well, Rob, thanks again for taking the time. Really appreciate it.
Eric, thanks so much. I appreciate you having us on.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.